Yo, what's going on guys, Tanmay here for Simple Snippets and welcome back to another video tutorial on data structures and algorithms, and today's topic is going to be Radix Sort sorting algorithm. So as the title of the video suggests, I'm going to be dividing this Radix Sort sorting algorithm into three parts, that is three videos, and this is the first part where we are going to discuss a little bit of theory and we are going to take an example and go through the working, that is the step-by-step process of how Radix Sort algorithm works. So if this topic or this sorting algorithm is completely new, make sure you watch this video till the end and I can assure you you will understand the entire working, because we are going to take a visual diagram and dry run that working onto this example that we are going to take. And in the second part, we will take the pseudocode, we will again dry run the pseudocode on the same example, and the third part is where we write a C++ program to implement the Radix Sort sorting algorithm. So the reason why I've divided it into three different parts is I don't want to put everything in one single video, that would be a little boring for you. But make sure you watch this in this proper sequence, that is part 1, part 2 and part 3, and also make sure that you watch this video in one go till the end, because that's how you get the best understanding. And with that being said, let's get started. If you're new to my channel, my name is Tanmay Sakpal and I do a lot of computer science and information technology video tutorials like computer programming, development, technology talks and a lot more on this channel. So if that's something you're interested into, then definitely subscribe and turn on the notifications to get the latest updates and never miss out on such important topics. Okay, so starting off with a little bit of theory, if you're making some notes, if you're preparing answers, you can note these points down. I'm obviously going to be sharing them on our official website, so you can go check that out. But starting off, Radix Sort is a non-comparative sorting algorithm. So this non-comparative is very important. So typically the sorting algorithms that we've seen, that is the selection sort, insertion sort, bubble sort, we have quick sort, we have merge sort, all those sorting algorithms were pretty much comparative sorting algorithms. And when I say comparative, what is happening is the elements that are there in the array or in the list or in whatever data structure are basically compared with each other, and depending upon which one is smaller or larger, some kind of swapping, some kind of switching, some kind of replacement is happening. So this is where comparison is happening. However, Radix Sort is a non-comparative sorting algorithm. Now if you've been following this data structures course, in the previous couple of videos of this playlist, we've covered counting sort, and Radix Sort actually uses counting sort also. So even counting sort was a non-comparative sorting algorithm which uses some mathematical arithmetic to determine the exact position of every individual element. And as I mentioned, since Radix Sort pretty much implements counting sort in a different way, hence it is also a non-comparative sorting algorithm. Moving on, the way this Radix Sort works is by creating and distributing individual elements into buckets according to their radix. Hence it is also known as bucket sort or digital sort. We'll talk about it, and these points might not make sense as of now because we're just going through them in terms of theory, but as you see the working, all these points will make sense, so make a note of them. Everything will make sense by the end of this video. So for elements with more than one significant digit, that is multi-digit elements, kind of like this 170, 45, 75, this bucketing process is repeated for each digit while preserving the ordering of prior step until all digits have been considered. And for this reason, Radix Sort has also been called bucket sort and digital sort. Again, this point also will not make sense as of now, but as you move ahead, you'll understand every point. Moving on, typically Radix Sort uses counting sort as subroutine. Now the obvious question arises that if Radix Sort ultimately uses counting sort, why not use counting sort directly, right? So if you take this example over here, in our array you can see we have elements or integers which have multiple digits. So 170 is a 3-digit element, that is 3-digit number. So if you apply counting sort for this, counting sort has a principle where we have to declare the range, right? So if you see these numbers, the largest number is 802. So the range here is from 0 to 802. So we are considering a range which is around 800 elements, which means that the count array is gonna be of size 800, because every individual element, every unique number has its own index position in the count array. That's how the mapping works, right? So elements in the input array are mapped to the index position in the count array. Remember that statement? We've talked about it in counting sort, and please make sure you watch counting sort first. It is very, very important because Radix Sort pretty much works completely on counting sort, at least in our example. So it's very important that you understand that. So in that case, the range is gonna be around 800. So the count array will have a size of 800. However, if you see the array elements, that is the size of an input array is only 8. So only 8 elements require count of 800 sized array. So 170 will be marked somewhere, the count will go plus plus. Then there will be 45 somewhere over here, that would be plus plus. And remaining all the values, that is the 800 elements, are gonna be 0. Except for 170, 45, 75, 90, 802, 24, 2 and 66. Only these values or only these index positions in the count array will store plus plus values, that is 1 value. That's how the count is measured. But remaining elements are going to be 0. So you can see a huge amount of space is wasted. And that is why directly applying counting sort on digits or numbers which are having more than one digit is not very efficient. It wastes a lot of space and it's absolutely impractical. So this is why Radix Sort uses counting sort in a way that Radix Sort takes this number, applies counting sort on one digit, then it applies counting sort on the next significant digit, and then it applies counting sort on the last digit, starting from right to left. So starting from the units place till the hundreds place, or starting from the least significant bit to the most significant bit. So that's the crux of Radix Sort, and you'll understand more as we take an example. And ultimately Radix Sort also has linear time complexity because it technically implements counting sort only, right? So the time complexity of counting sort, remember, was O of n plus k. N is the number of elements, so number of elements in the array, and k is the range. But here if you see there is an extra d. So this d stands for the number of digits that the maximum element in the input array or in the input list has. Okay, so over here if you see the maximum element is 802, right? So the number of digits it has is 3. So counting sort will be called 3 times, and hence this d extra is added over here in the time complexity. Talking about the space complexity, it's gonna be the same as the space complexity of counting sort, which is O of n plus k, because an auxiliary array, that is an extra array, is created to store the count, and an extra array is also created to store the output array. So the output array is gonna be of size n, which is exactly the size of the input array, and this k is for the range, which is the size of the count array. So this is all something that we've discussed in counting sort. But now moving forward, we've got a basic idea that Radix Sort is going to implement counting sort. So let's see how that implementation works. Let's see the working. Okay, so on the left hand side, we have written the working in the form of steps. So these are plain algorithmic English steps. Step by step, we go from step 1 to step 7. On the right hand side, we have our very same example, that is this array of size 8. And if you notice, I have added extra zeros on the left hand side, which does not actually change the value, but we've added these zeros because the maximum number here is 802, which is of 3 digits. So we want to make everything 3 digits just for comparison and calculation purpose. As we move ahead, you'll understand that. But let's go step by step and apply this Radix Sort sorting on this array, and let's see how it works. Okay, so step number 1, we have to take the input array and find the max number in the array. So obviously Radix Sort is going to implement counting sort, and that counting sort is called n number of times, and that n depends upon the number of digits the maximum element has. So for that, first we need to find out the maximum number, right? So take the input array, we have to take this and we have to say or calculate the max number. So over here max is 802. Of course, when we implement the code, we will use some for loop to iterate through this array and actually calculate the maximum number. Right now we are just going through step by step in the English steps format in the algorithmic way. So max number is 802. Okay. With this we understand that we have the maximum number 802, which has number of digits 3. Number of digits equals to 3. Okay. Now step 2 is to define 10 queues, each representing a bucket for each digit from 0 to 9. So let's first visually see this and then we'll understand step 2. So step 2 says define 10 queues, each representing a bucket for each digit from 0 to 9. Now, in counting sort, when we were applying plain counting sort, we were applying it on a range of 0 to 9. That is, all the numbers were single digit numbers. So the range was 0 to 9, which means 10 unique elements, right? So the range was 10, which is kind of like a constant. In this case also, even though our numbers are more than 0 to 9, obviously the range can go around 802 because the maximum number is 802. In Radix Sort, we apply counting sort to individual digits and not the entire number. So if you take one digit at a time, obviously it is gonna fall between 0 to 9 only. Hence, we only require 10 unique queues, each representing a bucket for each digit from 0 to 9. So when we are in a decimal system, we have 0 to 9 as the unique digits, right? So Q0 is gonna represent number 0. Q1 is gonna represent number 1. Q2 is gonna represent number 2. Okay? So that's why we've created 10 queues over here. You can see. Let me just erase few things over here. Okay, so we've defined 10 queues, and even if things are a little confusing right now, let's move to step 3. Let's follow the steps and things will get clearer and clearer. So step 3 is consider the least significant digit of each number in the list which is to be sorted. Now, which is the least significant digit for all these numbers? So least significant digit starts from the units place, that is from the right to left. For the first time, that is the pass 1, you can see I've written pass 1 over here. It's for a reason. For pass 1, the least significant bit to be considered is this units place which is marked in square pink boxes. So for all these numbers, this is the units place. So that's what we've considered. Now step 4 is insert each number into their respective queue based on that least significant digit. So we have to take 170. We have to go from left to right. Okay. You have to take 170. You have to consider the least significant digit which is 0 over here. And since it is 0, it will go in Q0. So I'm gonna write 170 over here. Then I will move forward to the next element. Next element is 045. The least significant bit that we are considering for the first pass is the units place, which is 5. So 045 goes in Q5. So it's gonna be inserted over here. So I'll write 045. Okay. Now these are resembling buckets, also known as queues. So the basic concept of queue is first in, first out. So whichever element goes first comes out first. So you'll understand that use case as we move ahead. But let's move to the next element. The next element is 075. Again, the units place is 5. So it goes in Q5. So I'm gonna write 075. Similarly, 090 will go in the Q0 because the least significant bit is 0. And 0 is for Q0. So 090. Then we have 802. 802, the least significant bit is 2. It goes in Q2. So 802. Then we have 024. 4 is the least significant bit in the units place. So we write 024 over here. Then we have 002. Again, it goes in Q2. 002. And then we have 066. So 6 goes in Q6. So 066. Okay. So step 4 is pretty much done. Now, step 5 says group all the numbers from Q0 to Q9 in the order they have inserted into the respective queues. So starting from the left queue, that is Q0 to Q9, we have to take each and every number in the way it was inserted and enter it into our original array. So in pass 1, we are performing counting sort in a way, obviously, because it doesn't look like counting sort right now because we are representing it in the form of buckets and queues. But when we implement the code, it is going to be counting sort. But what we're doing is we are sorting this array by considering only the units place in pass 1. Okay. So 170 was entered in Q0 at the very beginning because we started from 0, right? So we'll write 170 over here. Okay. So 170 comes over here. This is done. Then we have 090. So I'll enter 090. So Q0 is done. Then I'll move to Q1. We don't have anything in Q1. We move to Q2. So we take 802, which was entered first. So I'm going to write 802. This is done. Then the next was 002. So I'm going to write 002. This is done. Then I move to Q3. There's nothing in Q3. In Q4 we have 024. So I'm going to write it as it is. This is done. Then I'm going to move to Q5. In Q5 we have 045, which was inserted first in the Q5. Then we have 075. And lastly, in Q6 we have 066. Okay, so now step 5 is done, grouping of all the numbers from Q0 to Q9. So starting from Q0 to Q9 and in the order that they have been inserted in their respective queues. That's how we wrote them in our original array. And what we've done is we've sorted this array one time, that is for the first time, based on just the units position. Now if you observe, this array obviously is not sorted, right? 170 is coming at the first place where 002 has to come. But this is not the end of this Radix Sort sorting algorithm and we have still more steps. So let's move to step 6. And in step 6 it says repeat step from step 3, step 4, step 5 based on the next least significant digit. So you can see now that the next least significant digit is the tens place, because we have 3 digits in the maximum element. We have to do this pass 3 times. So we have just done one pass. Now we will move on to the next least significant digit, which is the tens place. Also this time the sorting will be applied on this newly formed array. So the tens place to be considered is for this array and not the very first one, because we've transferred the elements into the same array, right? So you can see ARR and ARR. So now we have to apply this radix sort on this newly formed array by considering the tens place. Okay, so I'm marking them in pink circle so that you can see it clearly. And now let's do the pass 2. Now pass 2 again is repetitive. We have to do step 3, step 4 and step 5 again, but this time we have to consider the tens place. So let's start from left to right. That is the first element in this new array. I'll use some other color. Let me use yellow. Okay, so first we have to take tens place, that is the 7. So it goes in Q7. So 170 is pushed over here. Okay, 170 goes in the Q7 because the tens place has 7. Then we have 090. So 9 has to be pushed in Q9. So 090. Then we have 802. So 0 is for Q0. So I'll put 802 over here. Then we have 002. And the tens place has 0. So again 002. Moving forward we have 024. And we are considering tens place, that is 2. So it goes in Q2. So 024. Moving forward we have 045. We are considering 4. So it goes in Q4. 045. Then we have 075. It goes in Q7. So 075. And lastly we have 066. It goes in Q6. That is 066. Okay. So step 4 done. We've considered least significant digit. This time is the tens place because units place is done. Pass 1 is done. We are doing the pass 2. Step 4 is also done, inserting each number into their respective queue. Now step 5 again. We have to group them together starting from Q0 to Q9 in that particular order the way it was inserted. So 802 comes first, right? Then we have 002. We don't have anything in Q1. We move to Q2. We have 024. We move to Q3. We don't have anything in Q3. We move forward to Q4. We have 045 over here. Then we move to Q5. We don't have anything. Q6 has 066. We move ahead. We have 170. Then we have 075. So it's pushed out from over here. So 170 goes first, then 075. And lastly we have Q9, which is 090. Okay, so this was pass 2. Again, step 5 done. We come to step 6. In step 6 again we have to say repeat the steps 3 to 4 and 5 on the next least significant digit. So we still have one digit left, which is the hundreds digit. We just applied this radix sort sorting on the tens place. So we still have one more pass. If you observe this array, it is still not properly sorted. So now we have to sort this array 8 based on the hundreds place. That is this digit, this digit, this digit, this digit, this and this. Okay, so let's do the pass 3 and I'll use another green color. Okay, so starting off again, consider the least significant digit. This time it's the hundreds digit. Step 3 is done. Move forward to step 4. In step 4, insert each number into their respective queues based on the least significant digit. So this time the first number 802, we are considering 8, so it goes in Q8. So I'm gonna write 802 over here. Then move forward 002. This time we are considering 0, and this is the reason why I added 2 extra zeros to the left. I hope you understand now why we've added extra zeros. It doesn't add any real value to this number, but it helps us do this proper comparison or proper calculation. So 002, we are considering the hundreds 0 place. So I'm gonna write 002 in Q0. Move forward. Then we have 024, so I'll write 024. Then I'll move forward. We have 045. We are considering zeros, so everything is going in Q0. Then we have 066. I'll write 066. Move forward. We have 170, so this goes in Q1 because we are considering 1. Again another 075, and we are pretty much losing space, so 075. And lastly we also have 090, so I'll write 090. Please excuse me for this bad representation, but we didn't have space over here. But anyways, now Step 4 is done. Moving on to step 5, which is group all the numbers from Q0 to Q9 in that particular order that they have been inserted, starting from 0 to 9, that is Q0 to Q9. And so 002 comes over here, that comes out first. Again 024, then we have 045, then we have 066, we have 075, and lastly we have 090. So this is in Q0. Then we move on to Q1, we only have one value, 170, and lastly we have only one value in Q8, that is 802. Between all the Qs are empty, we have nothing over here. But now if you observe this array, this is in proper ascending order. So if I just erase out these extra zeros, so there you go, we have 2, 24, 45, 66, 75, 90, 170, 802, which is exactly in proper sorted ascending order. So lastly we come out of step 7, because step 7 says repeat step 2 until all the numbers are grouped based on the most significant digit. And the most significant digit is the hundreds digit over here, because that's the maximum number of digits, which is 3 for 802. And this is where the algorithm will stop. And now you can see we have a proper sorted array. So a quick summary to what we did in the Radix Sort algorithm. We take all the elements, we calculate or find out the maximum number from those elements. Then we calculate the number of digits it has, and that becomes the number of passes. So if we have a number which is in thousands, it would have 4 digits, right? So we would have one more extra pass. Then we create 10 buckets or 10 queues, and each bucket represents one digit from 0 to 9, because we only have 0 to 9 in the decimal system. So Q0 will be for 0 number, Q1 will be for 1 number, Q2 will be for 2 number, and so on and so forth. After this creation of buckets, we take every number, we take its least significant digit. So in pass 1, that would be units place. We see which number is that. If it is 0, we put it in Q0. If it is 1, we put it in Q1, and so on and so forth. We do that to all the numbers, and then we group all those numbers from Q0 to Q9. So we'll start from Q0 to Q9, and we pop them out, that is we dequeue them in the same order that they were inserted. So if 170 was inserted before 090, then 170 comes out first, and we put that in the same array, the same input array. So this is pass 1. For the next pass, we consider the next least significant digit, which is the tens place. Then we move to the hundreds place. Then we move to the thousands place if we have that, and so on and so forth. So we repeat this process, and ultimately at the end of exhausting all these digits, we have our sorted array. So yeah, this was the overall working and visual diagram of how the buckets are created. In the next video, we will see the pseudocode for Radix Sort algorithm, where the counting sort algorithm comes into picture. Because over here, I just showed you the concept of Radix Sort, that is the working, but programmatically how it works and how counting sort is added and used inside Radix Sort is what we will see in the next tutorial in the form of a pseudocode, and we'll implement that pseudocode on this very same example, and again visually see how step by step the working goes. So that's it for this video, guys. If you like this video, if you understood the overall working of Radix Sort, please give this video a like. Let me know in the comments how this video was. Do share it with your friends. Do turn on the notifications, because the next video is part 2 of Radix Sort, where we discuss the pseudocode, and then obviously the part 3 where we write a program. So all these videos will be there in this DSA playlist. I will link that in the video description. Do check them out. There are many other tutorials also. And with that being said, see you in the next one. Peace.